The following content is created by Dr. Avitek. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome, ladies and gentlemen. In this video, we'll ask to solve this very problem. It says we should find the half-range sine series for the function f of theta equals theta squared in the range 0 to 4. Now remember that since the range has been halved, that means the full range will be 8. The full range will be 8. So the period of this function is actually 8, and we're treating the function as an odd function. So we're doing an odd extension of this function. That's why we're asked to find the sine series. So involve only the sine terms. So involve only the sine terms means we're only going to be finding b sub n. So to find b sub n, and as an odd function, b sub n will become 2 over L, integral from 0 to L, f of x, sine n pi x over L dx. But in this case, we can see that our function is actually theta and not x. So we could rewrite all of this to become 2 over L, integral from 0 to L, f of theta, sine n pi theta over L d theta. Okay, next, what is L going to be? What is L going to be? L is 4. L is always half the period, so L is 4. Or you could say, if the full period is 8, so L, let me kind of do it here. L is your period over 2, so this is 8 over 2, so L is going to be 4, because L is half the period. And since they've taken the half already, which is 0 to 4, that means L is just 4. So this will become 2 over 4, integral from 0 to 4. F of theta is theta squared, sine n pi theta over 4 d theta. All right, now we could reduce this. 2 over 4 will give us a half. So this is half, integral from 0 to 4, theta squared, sine n pi theta over 4 d theta. Okay, now let's integrate. To integrate this function, we're going to be using integration by parts. So this will be 1 over 2. I'm going to write theta squared first. It's just a faster approach. So I'm going to write theta squared first. Now I'm going to differentiate theta squared until I get 0. So differentiate theta squared, I'm going to be getting 2 theta. Differentiate 2 theta, I'm going to be getting 2. Now when I differentiate 2 again, I'm going to get 0. But you know that's kind of useless. So I'm not going to go to 0. I'm just going to end at that number. Now this sine here, I'm going to be integrating the sine part of it. So let's integrate sine. So integrate sine, you get minus cosine. So this is minus cos n pi theta over 4 divided by, you must divide by the derivative of the angle. So you must differentiate the angle. When you differentiate this angle with respect to theta, you get n pi over 4. So you must divide by n pi over 4. Next, so this is for this first part. Now for 2 theta, we're going to be integrating this bracket again. So to integrate this bracket, there's a minus here, so I'm going to write minus. When you integrate cos, you get sine. So this is sine. Then you put in your angle, n pi theta over 4, divided by, you differentiate the angle again. So when you differentiate this angle, you get n pi over 4. Now the n pi over 4 will meet this previous n pi over 4, because you're actually differentiating, you're actually integrating everything here. So it's going to meet this one again. So make it n pi over 4 all squared. So that's for this one. Now, for the 2, we're going to be integrating this whole bracket again. So integrate this whole bracket. You write your minus first, minus. When you integrate sine, you're going to get minus cosine. So this is dot minus cosine. Then you put your angle, n pi theta over 4. Then divided by, when you differentiate this angle, you get n pi over 4. So it's going to meet this one. So make it n pi over 4 cubed. Then you're going to close this up. Now the correct sign to go about all of this. This will be plus, minus, plus. And then our limit is 0 to 4. Now, if you should use integration by parts, your result will still be the same. If you want to use integration by parts, you're still going to have the same answer. Now, let's simplify this whole bracket. It's looking too, should I say, bulky. So let's do this. This will be a half. And then this is a negative. So let's say this is negative theta squared cos n pi theta over 4 divided by n pi over 4. Okay, now minus times minus is plus. So this will be plus 2 theta sine n pi theta over 4 divided by n pi over 4 squared. All right, now this is plus 2, this is minus, and this is minus. So this is all plus. So this will be plus 2 cos n pi theta over 4 divided by n pi over 4 all cubed. Okay, and that's from 0 to 4. All right, as always, our sine will always give us 0. Now, if our theta is 4, 4 over 4, that's 0. So, sorry, 4 over 4 is 1. So, 1 times n pi is n pi. Sine n pi is 0. So, this guy is gone. Also, when you put in your limit as 0, 0 over 4 is 0. 0 times n pi is still 0. Sine 0 is 0. So I could just take this out. It's just going to be 0. So just remove it anyways. It's going to be 0. So this will be a half. And let us get started with our limit. So let's put in 4. Let's put in 4. So this will be minus 4 squared cosine of, if we should put your 4 here, if we should put 4 here, this will become 4 over 4. So that's just 1. 1 times n pi is n pi, so this is n pi, divided by n pi over 4. So this is for that part. Now for this part, let's put in our 4 here. So this is plus 2 cos. If we should put in your 4 here, 4 over 4 is 1. 1 times n pi is n pi. So this is n pi, divided by n pi over 4 cubed. Now, this is when you evaluate your your upper limit. So that's for your upper limit. Then minus, the lower limit, theta will be 0. Theta is going to be 0. Oh, that's beautiful. So if theta is 0, this will become minus 0 squared, which is basically still 0. Cosine of, when you put 0 here, n pi times 0 is 0. 0 over 4 is still 0. Divided by n pi over 4. Then plus, this is 2 cos, this will still be 0, divided by n pi over 4 cubed. I was thinking this would be beautiful. That was why I was like, that's beautiful. It's not beautiful, actually. Okay, and then this will be from, yeah, I'm going to close that up. Okay, now we know this is 0, because 0 squared is still 0. 0 times this will give us 0. So basically, everything there will be 0. Then we're going to be having 1 over 2, and then minus 4 squared is 16. So this is 16. Cos n pi has a special value, which is minus 1 to the power of n, divided by n pi over 4. And then plus 2. This right here, cos n pi again, is minus 1 to the n, divided by n pi over 4 cubed. And then, for this one, this is 0 already. So minus times the second part, minus times the second part will give us minus 2. Now remember that cos 0 is 1. Cos 0 is 1. Then divided by n pi over 4 cubed. So this is what we have. I actually thought it's going to be beautiful. It's not. Okay. So, to simplify this expression, the only thing I am aware of is, let me simplify this denominators. Let's do something about that. So this will be 1 over 2 into negative this 4 can come to the top. If this over 4 comes to the top, this will become 64 into minus 1 to the power of n divided by n pi. Plus, this is 2 into minus 1 to the n divided by n cubed pi cubed divided by 4 cubed, which is 64. So let me basically just write 64. And then minus 2 divided by n cubed pi cubed divided by 64. Okay, so this is 1 over 2 into minus 64 minus 1 to the n over n pi plus, this 64 can come to the top. So 64 times 2 will give us 128. So that's 128 into minus 1 to the n divided by n cubed pi cubed. And then minus, same thing happens here. This will be 128 divided by n cubed pi cubed. Okay. This is looking very, very fine in a way. Okay. Now, this is half. If I take half of everything here, it means I'm going to be dividing the numerators by 2. If I take half of every single thing here, I'll be dividing the numerator by 2. So this basically means I'll be having minus 32 into minus 1 to the n divided by n pi, and then plus 64 into minus 1 to the power of n over n cubed pi cubed, and then minus here, this is 64 divided by n cubed pi cubed. That's what I have. Okay. I do not want to factorize. I don't want to factorize. So I'm going to leave this part like this. I'm going to leave this part like this. So this will become minus 32 into minus 1 to the n divided by n pi plus, I kind of have 64 and 64. I have n cubed pi cubed and n cubed pi cubed. So I could factorize that out. So this is 64 divided by n cubed pi cubed into, what will be left will then become this, minus 1 to the power of n minus everything here will just be 1. Since I'm kind of factorizing, that's what I'm going to get, since I am factorizing. Okay. Next, this bracket could be 0 at some point. This bracket here could be 0 at some point. And then I could have a simplified version of the answer. So let's assume that n is odd the first time. So let n be odd. So when n is odd, we're going to be having minus 32 into minus 1 to the power of, let's pick an odd number, let's say 1, divided by n pi. Now remember that the n pi is not our business, because this n pi would have a different value for some numbers. But the minus 1 to the power of 1 will not be having different values. And this will be plus 64 divided by n cubed pi cubed into minus 1 to the power of 1 minus 1. So this will be minus 32. Now minus 1 to the power of to the power of 1 is just minus 1 over n pi plus 64 divided by n cubed pi cubed. Now minus 1 to the power of that will give us minus 1, then minus 1. Now this will be minus times minus to give us plus. So this is 32 over n pi. Then minus 1 is minus 2. Minus 2 times 64 will give us minus 128. So this is minus 128 divided by n cubed pi cubed. So this right here is when n is odd. When n is odd. Alright, so I'm going to just leave it like that. I don't want to do much. Unless I could say, let me factorize the 32 outside. But I want to leave it like this first. Then next, when n is even, our b sub n would then become, this is our b sub n. So this is minus 32 into minus 1 squared over n pi. Then plus 64 over n cubed pi cubed into minus 1 squared minus 1. Okay, so this is minus 32 over n pi Minus 1 squared is 1. It's positive 1. So 1 times anything is that same thing. So that's why this will be remaining. Plus 64 divided by n cubed pi cubed. Now, minus 1 squared is 1. And then we'll have minus 1. So this is minus 32 over n pi because 1 minus 1 is 0. 0 times this whole stuff here is going to be 0. So this is your b sub n if it is odd. This is your b sub n if you have an odd item. This is what you have. Okay. Many a times I try my best to see if I can make my expression much more beautiful. I kind of try to see if I can do that. Yeah. But sometimes it's actually very difficult. So what I'm going to do next is, since this is when n is odd, I want to find b1, b2, b1, b3, b5 for the odd values. So let me find b1. So 1 is odd. So when n is odd, we are having this value. So this will be 32 over 1 times pi is pi, and then minus 128 divided by, this is pi, right? So this will be pi cubed. So this is what we have. Now, to simplify this whole expression, as you can see, 32 over pi will be common. So that's why I was like, maybe I should just factorize that. So 32 over pi is common. Then I'm going to open up a bracket. This will then become 1 minus 128 divided by 32 is 4. So this will be 4 over pi squared. So I could just leave my b1 like that. So that's b1. Next, b3. So for b3, anywhere I see n, I'm going to be putting 3. So this will be 32 over 3 pi. So that's 3 pi minus 128 divided by 3 cubed, pi cubed. Now again, 32 over pi will be common. So this is 32 over pi into, what will be left here will become 1 over, 32 over 3 pi will be common. Yeah. Because this is 32. There's still 32 at the top. This is 3 pi. This is still 3 pi. So 1 will be what's remaining here. Since I'm bringing out everything here. Minus 128 over 32 is 4. Divided by what will be left here will then become 3 squared pi squared. So that's what I have. Now let's find b5. You know you can actually tell what b5 would be. Yeah, b5 is going to become 32 over 5 pi into we're going to have 1 minus 4 into 5 squared pi squared. Yep, it follows a particular pattern. So this is what we have. That's what we have. So yeah, this is my, for odd values, this is my b1, b3, b5. Now, this one, to find your b2, b4, b6, they're going to be easy actually. So let me just do that one here. Don't worry, I'm going to know, I'll know where I put my values. So my bn when it's odd, I could say that that expression is minus 32 over pi into 1 over n. I could write it like this. So my b2 will become minus 32 over pi into 1 over 2. My b4 will be minus 32 over pi into 1 over 4. My b6 will be minus 32 over pi into 1 over 6. That's what I have. So finally, let us get the Fourier series of this very function. Let's get it. So the Fourier series for this will be f of x equals the sum from n equal to 1 to infinity of b sub n sine n pi theta. So this will be f of theta, over L. Okay. So this will be the sum from n equal to 1 to infinity of b sub n sine n pi theta over 4, because L is 4. Now, if you look at this expression, what we ought to do is to say we're going to get when n is 1, so this will be b1, when n is 2, b2, when n is 3, b3, just like that. So let's have when n is 1. This will be b1 sine, n is 1, right? So this will just be pi theta over 4. And then plus, next one, b2. So this will be b2 sine n is now 2. So what is 2 over 4? That's 1/2. So this will be n, no, not n, that would be pi theta over 2. And then plus b3 sine. Now n will be 3. So this will be 3 pi theta over 4. And then plus b4 sine. When you put 4 here, 4 will cancel at 4. So this will just be pi theta. And then plus, we're going to have 5. So that's b5. I feel like this is actually a lot. That's actually a lot. So this is b5 sine 5 pi theta all over 4 plus b6 sine. When you put in 6 here, 6 pi will just give us 6 pi. Then when you divide it by 4, that will be 3 pi theta over 2. And then just like that. Now, anywhere I see my b1, let me start putting the values. Even though I kind of know, yeah, these are the values. So let's put in b1. So b1 is this. So that's 32 over pi into 1 minus 4 over pi squared. That's b1. Then you say sine pi theta over 4. Then next is b2. This is b2. So b2 is minus 32 over pi into 1 over 2. Then sine pi theta over 2. Next, b3. So b3, this is b3. So that's, excuse me, that's 32 divided by 3 pi into 1 minus 4 divided by 3 squared pi squared. And then we're going to have sine 3 pi theta over 4. Then plus b4, this is b4. So that's minus 32 over pi into 1 over 4 sine pi theta. The next is b5. So this is plus b5. This b5. So that's 32 over 5 pi into 1 minus 4 divided by 5 squared pi squared. Then we have sine 5 pi theta over 4. Then 6. This will be minus, this b6. This minus 32 over pi into 1 over 6 sine 3 pi theta over 2. Now, if you look at this whole expression, it's a lot. So what I want to do is to write it in bulk, write it in a full item. So I want to write it when it's full. This is 32 over pi. It's almost everywhere. So I could actually factorize that out. So this is 32 over pi. Then I open up a very big bracket. If I remove 32 over pi from here, what I'll be having left is 1 minus 4 over pi squared bracket sine of pi theta over 4. That's for the first part. Minus, when I remove 32 over pi from here, what will be left is just this. So this will be half sine pi theta over 2. When I remove 32 over pi from here, this will be 1 over 3 will be left. So this is plus 1 over 3 into this. So that's 1 minus 4 over 3 squared is 9. So this is 9 pi squared. Then I have sine 3 pi theta over 4. Okay. Next, minus. When I remove 32 over pi from here, this will just be 1 over 4 sine pi theta. Plus, when I remove 32 over pi, this will be 1 over 5 into 1 minus 4 over 25 pi squared. Then I have sine 5 pi theta over 4. And then minus 1 over 6 sine 3 pi theta over 2. Just like that. And I'm going to close this up. Now, this will be the answer. What if the equation says we should leave our answer in terms of n? In terms of n. That is the Fourier series. We should leave it in terms of n. Now, remember that the Fourier series f of theta is the sum from n equal to 1 to infinity, b sub n sine n pi theta over 4. That's the Fourier series. So let's put our b sub n. So this is the sum from n equal to 1 to infinity. Now our b sub n had a simplified value of minus 32 into minus 1 to the power of n over n pi plus 64 over n cubed pi cubed into minus 1 to the power of n minus 1. So this is our b sub n. This is your b sub n. And then sine. So this will be sine n pi cubed all over 4. Now this will be the Fourier series of the function in terms of n. This is the Fourier series of the function in terms of what? In terms of n. Now what if you're asked to expand? This is the expanded form. This is the expanded form, while this is the Fourier series in terms of what? N. So with this, we're going to conclude this very video, and I'll see you in the next one.